Hey, 7th grade. Hopefully you enjoyed my other videos. Yeah, this is a learning curve for me a little bit, especially without my cameraman. I'm doing this by myself mostly. But hopefully you can see that my video taking is getting better. First one was not so great, second one maybe a little better, so hopefully this one will be even better than that. So yesterday, or last week, I guess I should say, we learned about kinetic energy. Kinetic energy is the energy of motion. Now we are going to be introducing another energy called gravitational energy. So this gravitational energy is a type of potential energy, and most times you will hear it called potential energy, but it's important to remember that potential energy is really a category of different energies. So potential energy is any energy that has stored energy, or any energy that has the potential to move. That's why it's called potential energy. So it has potential to move. So not only is that gravitational energy, but it's also chemical energy, electrical energy, elastic energy. So it's more of a category, but a lot of times you will hear potential energy as gravitational energy. So gravitational energy is the energy associated with elevation. All right, so when you have something elevated and you drop it, it has the potential to move. The only energy really that will be, there might be another one, but that won't be a potential energy is kinetic, and I think thermal actually. But kinetic energy can't be a potential energy because it's already moving. So if it's already moving and has kinetic energy, it can't have the potential to move. So just remember that as well.
I'm not going to hold it like this.
Okay. So potential gravitational energy is the distance between an object and Earth. An object raised higher in the air has more gravitational energy than the identical object raised slightly off the floor. So, which one of these applesauces has more gravitational energy? The one Henry's holding up or the one Natalie's holding up? Alright, so I'm back inside. It's a little chilly, and here I can actually stand my phone up. So here we have flashcards that I'm going to drop. Any elevated object has gravitational energy. So it's elevated, has gravitational energy. Alright, so think to yourself, if I'm just holding on to an object, does it have any energy? Does it have the potential to move? Alright. Something that you can kind of debate with yourself or with your family members is if this is not raised, it's just on the floor, does it have any energy? Would the object fall if it was not raised? Does it have the potential to have any energy if it's just sitting there? Something to think about, but anyway, that's a fun debate topic in class. Alright, so I'm going to drop these flashcards. I'm going to move back so you can see me. And we are going to be looking at how an object falls and what happens to the gravitational energy and kinetic energy as it's falling. All right, so I'm going to drop it and then we'll kind of dissect it. One thing to keep in mind is we are going to be stopping our measurement of gravitational and kinetic energy like the millisecond before the flashcards hit the ground. It's called the impact speed. So that split second before it hits the ground, right? So here's the object falling. All right, so our learning targets for today are to try your best to understand the relationship between kinetic and gravitational energy. Also, to try your best to understand what an energy conversion diagram is. So an energy conversion diagram is I'm going to be drawing it right here. And it's usually a series of circles, and you make little pie charts of all the different energies that are involved. Okay, so an energy conversion is an energy that can be converted from one type to another. And all the different energies can be converted into all different types of energy. Today we're just focusing on kinetic and gravitational. All right, so when I was holding on to the flashcards, that's step number 1 here, I was holding on to it. It had the potential to move, but it wasn't moving, so we have all gravitational energy, so I'm just going to leave it blank. Okay. Then I also did number 5 for us. So remember, number 5 is our impact speed, the moment right before the cards impacted the ground. All right, they did do a little flip and a flop, but we're going to ignore that for now. Okay, so we're just measuring right before it hit the ground. It's called impact speed, so that is the most speed it's going to have, so it is all kinetic energy. So then we go and think about, what does 3 look like? Well, if you notice, 3's kind of in the middle. It's in the middle of its journey, so what do you think circle number 3 would look like? Well, if you're thinking it would be half, well, that's a little, not the greatest half I've ever seen, half kinetic and half gravitational, you would be right. So the way I always do these energy conversion diagrams, and you're going to be mostly describing them, and we'll be doing them for you, but this is what usually we'd have you do, is trying to figure out what would 2 and 4 look like from that. And I would always start kind of like a clock, go clockwise. So start here and go around and kind of fill it in that way. So if we have 1 all gravitational, 1 all kinetic, then we have half and half. What would 2 and 4 look like? If you're thinking fourths, you are right. So it's gaining kinetic energy, gaining even more, gaining even more. So it's gaining, gaining, gaining speed up until 5, and then boom, hits the ground. So what's happening? Questions to ask yourself, what's happening to the object's gravitational energy? Is it increasing or decreasing? And what's happening to the object's kinetic energy? Is it increasing or decreasing? And did the object have the same amount of kinetic and gravitational energy at the same time? All right. I believe I can set you free to now complete task 1. Good luck.